Okay, so we are going to talk about linear versus nonlinear functions. So when we get done with this lesson, you should be able to look at an equation and determine if the function is linear or nonlinear. And you should be able to also do it if I give you a X and Y table or a input-output table. You should be able to look at it and say, yes, this is linear, or no, this is not. Okay, so linear versus nonlinear functions. What you are looking for linear, for line, is you're looking for those that have an exponent of 1. Okay, exponent of 1. So on this one, y has an exponent of 1 and x has an exponent of 1. So this is linear. On y equals negative 2x to the fourth, y has an exponent of 1, but x does not. So this is not linear. This one, y has an exponent of 1. Here, x is the exponent. So this is actually, it is not linear. And more specifically, just an FYI, this is called an exponential function. Some of you may have seen these before, and this is when you end up with a graph that looks like this in curves or curves the other direction. At any rate, it is definitely not linear. It is not a line. It is not a piece of a line. Y equals x. Some of you might be thinking, no, this doesn't work because there's no numbers involved. Well, this has an exponent of 1, exponent of 1. This is also linear. This one, y equals 4 over x. X is in the denominator. And what you will learn is in a couple sections we'll be talking about exponents. This is the same thing as 4x to the negative 1. Again, I'll explain that later. But because this is in the denominator, that means it's going to have a negative exponent. This is also not linear. Okay, so there's 5 examples of linear versus nonlinear functions given an equation. If we do the same thing, the linear versus nonlinear, but we look at a table instead. We can either look at the x and y table or the x and the f of x table. It doesn't really matter. What you are looking for is a constant change. So 0, this goes up 1. This goes up 1. And this goes up 1. This goes up 2, and up 2. So from 4 to 6, we went positive 2 or up 2, up 2, up 2. Everything is constant. This is linear because it has a constant rate of change. We will talk more about rate of change and slope next unit. Okay, so that is linear. It's another x and y table. Okay, so this has up 3, and up 3. But from 2 to a negative 1, we went down 3. Here we went down 1, and here we went down a half. This is not linear because it does not have a constant rate of change. Let's do another one. So here we went up 3, added 3, and added 3. Some of you might be looking at the other side in the Y column or in the output of saying, well, it is constant. But if I add 4, that gives me here, but if I add 4, that does not give me to 16. So adding 4 is not a constant change. But if I multiply by 2, even though this is the same number, if I were to graph this, you would not get a line. Let's kind of sketch this out real quick. Negative 2 and 4. 1 and 8. 4 and 16. Oopsie, negative 2. 1 and 8 is over here. I screwed up. 4 and 16. Going way up here. 8, 16, 7, and 32. You're going to see that it's going to be a curve. Oopsie. It's going to be a curve that looks something like that. So again, this is not linear. So when you're talking about linear, we are looking at either adding a constant number or subtracting a constant number, not multiplying. That's when you start getting into your exponential functions.